All right, this is the last lesson for this course, and we're just doing a very brief overview of solving systems, and we looked at how to solve systems graphically, and now we want to look at using an algebraic method, because sometimes when we use a graphing method, we get kind of approximated answers, and we don't want approximated answers, right? We want very exact answers. So substitution or an algebra strategy will help us get those exact answers. All right, so how can we solve this linear system algebraically? We're going to use a strategy called substitution. And there is another strategy that we typically cover called elimination, but it works pretty much the same way. And I think substitution is just really kind of a better strategy altogether. So we're going to use that. And if you want to kind of read further or look further into other methods, look up elimination. That's another kind of strategy that we could use. Yeah, it does exactly the same thing. Either of them will work. Okay, so let's figure out how we do that. So what we do is we kind of look, remember what a system is. 2x minus 3y equals -1, and y equals x minus 1. So a system for us is two equations where there's the same variables in each equation, right? And they represent the same quantity. And we want to find the pair of values that satisfies both equations. So what number for x and what number for y would show up in both equations. Okay, so the way substitution works is it works really well when you have an isolated variable. See how we have this y all by itself, and we know that y equals x minus 1. Okay, so I can take that value of y. Wow, that's very blurry. All right, things are slowing down for me here on my laptop working late at night. All right, so y equals x minus 1. So we want to take that value of y and we want to put it in the other equation where that y is. Okay, and watch what we get. Normally we have 2x, right? That's in our equation, minus 3. And instead of writing the y, let's write the value for y. And the value for y is going to be x minus 1. And that still is supposed to equal -1. So see what we did there. We took two equations that have two variables, and through substitution we created one equation that has one variable in it. And now we can use our grade 9 kind of algebra skills to be able to solve this, multi-step algebraic problem. So first step, distributive property. So let's distribute that -3. Watch, -3 times -1 is +3 equals -1. And we're going to collect our like terms. 2x and minus 3x is minus x. We still have a +3 equals -1. And we're going to move that -3 over. We're going to subtract 3 from both sides. So we get -x equals -4. Okay, so go back and just kind of watch what I did there. I'll scratch this guy out better. Okay. Go back and kind of watch this if you need to see what we did there. Okay, but you've solved these kind of problems before. I don't want to know what -x equals. I want to know what +x equals. So if -x equals -4, then because I can multiply both of these by -1, +x equals +4. Right? And we're halfway done. We're more than halfway done because that's the hard part. The easy part now is, well, if y equals x minus 1 and x equals 4, trying to make that not so blurry for you, then y equals 4 minus 1. Right? We're just substituting back here. So y equals x minus 1 and x equals 4, then y equals 4 minus 1. So y equals 3. And that's it. That's our answer. X equals 4, y equals 3. And we want to check this guy, right? We want to go back and see it's 2 times x, which is 4. 2 times 4 is just 8 minus 3 times 3, because y is 3, is 9. 8 minus 9 is negative 1. Perfect. And then y equals x minus 1. So 3 equals 4 minus 1. Sure does. Perfect. So we're good. So our answer works. So we'll always know if we have a correct answer. All right, so let's write down just a quick couple of things that we did here. We substituted the value of one variable into the other equation. So we had that isolated y, and that meant y is equal to x minus 1, and we substituted that value into that top equation, right, to make one equation to solve, right? So we made this one equation here that we used our good algebra skills to be able to solve for, and then we used that value to solve for the second variable. Okay, and I know that looks really complicated, but if you can kind of get the hang of doing this one step here, that's the only thing that's new in this whole process, is this substitution. It's creating this equation. You've done a whole bunch of practice in getting, in solving the algebraic equations yourself. Okay, this looks like a very messy system. I'm not sure what kind of answer I'm going to get here. All right, no, we're not going to solve the one that's in your notes. We would need to use a calculator for it. Yeah, no, we're not going to do it. So I just found another one quick that we can do instead that demonstrates the same things, and it doesn't have big gross numbers in it that we have to worry about. All right, so let's look at this system. 2x plus 3y equals 15, and x minus 3y equals 3. It's a great system. We've got x's and y's. We've got two lines. And what we're really looking for is those values of x and y. That one value of x and y that's going to satisfy both equations. Problem with this guy is it doesn't have an isolated variable. Right? Our last question had that y all by itself, and it was really easy to take its value and put it into the other equation. So if you don't have an isolated variable, then what you do is make one isolated, right? We have equations here, and as long as we do the same thing to both sides of the equation, we can kind of do whatever we want. So that's kind of the power of algebra. That's what makes all of this just kind of wonderful. If we can get the rules in place, we can kind of do whatever we want. All right, so I think the easiest one to isolate here is this x, right? It doesn't have a coefficient, so we can get this x all by itself. So I can rewrite this guy as x equals positive 3y plus 3, right? And I can just kind of write this guy still, just like it was. Okay, and now what I can do is I can take this value of x and I can put it into that variable right there. So it doesn't matter if you can isolate x or y, it doesn't matter. But as soon as you can isolate one, you can put its value in place of the variable in the other equation. So now this top equation becomes 2 times 3y plus 3 plus 3y equals 15. And when we do distributive property, we get 6y plus 6 plus 3y equals 15. Collect our like terms. 6y and 3y is 9y. And then I'm going to move that 6 over. I'm going to subtract 6. I'm going to subtract 6 from both sides of the equation. So I'm left with 9y equals 9. Well, if 9y equals 9, then 1y equals 1. Okay, and x is 3 times the value of y plus 3. So x equals 6. And that's it. We solved our problem. And if you graphed both these lines, if you turn them both into y equals mx plus b's, you would find that where it intersected was 6, 1. That's another way to write this equation, or write the solution to this guy. Okay, so if you don't have an isolated variable, move things around, follow good algebra rules, and you can create an isolated variable, right? We just move this 3y over to the other side of the equal sign, so we had an x by itself, right? So when is substitution a good strategy to use? Well, we don't really have another algebraic strategy, but it's best done when there's an isolated variable. But it's our only algebraic strategy. So we're going to use it whenever we need to solve algebraically.